Okay, hi friends, welcome to our channel. Today we are going to discuss about photoelectric effect. Okay, so now what is meant by photoelectric effect? If we take a metal, when light with sufficient energy fall on the surface of the metal, the electrons are ejected out of the metal. Okay. So, when the light with sufficient energy fall on the surface of the metal, the electrons will eject out of the metal. Okay. Now, how the electrons will eject out? First of all, this phenomenon is called as photoelectric effect. Now, in the metal, we have atoms, right? Now, the outermost electron is called valence electron, or we can say valency. Okay. There is attraction between nucleus and valency. Okay. We need energy to break the bond between nucleus and valency. There is a bond, there is attraction is present between nucleus and valence electron or valency. So, to eject the electron out of the surface of the metal, so we need to break the bond between the nucleus and electron, valence electron. Okay. The energy required to break, energy required to take out the electron from the outermost atom is called ionization potential, right? So, when the bond is broken, then the electron is ejected out from the metal. It is mainly depend upon nature of the metal. And ionization potential. Is mainly depend upon nature of the metal and ionization potential. If the ionization potential is less, then less energy is required to take out the electron. Okay. Now let us discuss about what are the factors required for the ejection of electron. So more factors, which is first of all threshold frequency. So threshold frequency. What is meant by threshold frequency? So threshold frequency is nothing but the minimum frequency required to eject the electron out of the metal, surface of the metal. So the frequency, the minimum frequency required for the ejection of electron. Here, not in all frequencies the electron could be ejected out. Only certain minimum frequencies only, depending upon the nature of metal here. So how much frequency is the metal? That much frequency or that much more frequency is required to eject the electron. See, when we take potassium metal, so not all the light rays could eject the electron. Only the light rays with frequency compared to the nature of the metal, the frequency of the metal, the frequency of incident light should be compared to the minimum frequency, threshold frequency of the metal. In that circumstances only, the electron should be ejected out. Okay, will be ejected out. See, for example, potassium metal, when red light fall on the potassium metal, the frequency of potassium metal is 5.0 into 10 power 14 Hz. Okay, red light with frequency between 4.2 to 4.3 into 10 power 14 Hz. Red light with this frequency is not sufficient because potassium metal needed the minimum frequency of 5 into 10 power 14 Hz. But red light having only between 4.2 to 4.3. So, when red light is incident on the nature metal, potassium metal, the electrons cannot be ejected out. So, when violet light or yellow light, take for example yellow light, it has frequency 5.1 or 5.2 into 10 power 14 Hz. So this yellow light having sufficient frequency. Even when the violet light falls also, the electron will be ejected out because it also having sufficient frequency. So for example, a small trick here. So with GR, we have colors with GR, right? We have colors with GR. When it comes down to the colors, violet light, the wavelength is less, but coming to red light, the wavelength is more, right? So when wavelength is increases from violet to red, the energy decreases. The energy decreases. The wavelength increases while coming down. Okay. So we can write the energy is increases going to up. The wavelength is increases while going to down. The energy will be decreases going to down, and the wavelength is decreases going to up. Decrease, increase, increase, decrease. Okay, this is the relation among the colors, wavelength and energy. Energy decreases while going to down. So there is not sufficient energy when it comes to red light. But when it comes to yellow light there is a subtle, means there is equal, very close to the equal frequency for potassium metal. But the violet light, when we incident, there is a more chances of ejection of electrons because it has so much energy and sufficient frequency. Okay, there is another factor which will influence the ejection of electron. It is called wavelength. Threshold wavelength. What is meant by threshold wavelength? See, the maximum wavelength required to eject the electron out of the metal surface. Okay, the maximum wavelength means even when we take minimum frequency, the above values of the minimum frequency are also accepted, because when we above the minimum frequency means it is required. So అంటే ఫ్రీక్వెన్సీ ఎక్కువ తీసుకున్నా కూడా మినిమం కంటే ఎక్కువే కాబట్టి ఎలక్ట్రాన్ అనేది ఎజెక్ట్ అవుతుంది. కానీ ఇక్కడ మ్యాక్సిమం వేవ్లెంత్ అన్నప్పుడు అక్కడి వరకే వేవ్లెంత్ అనేది వస్తుంది. దానికంటే ఎక్కువ వస్తే ఆ ఎలక్ట్రాన్ అనేది ఎజెక్ట్ కాదు. కాబట్టి ఆ మ్యాక్సిమం వేవ్లెంత్ అంటే ఆ వేవ్లెంత్ పరిధిలోని ఆ వేవ్లెంత్ వరకే ఎలక్ట్రాన్ అనేది ఎజెక్ట్ అవుతుంది. ఇప్పుడు when we take red light, when red light falls on the potassium metal, the electron is not ejected out because it is far higher than the maximum wavelength. అంటే maximum wavelength కంటే ఎక్కువ ఉంది కాబట్టి రెడ్ లైట్ ఇన్సిడెంట్ అయినప్పుడు పొటాషియం మెటల్ మీద ఎలక్ట్రాన్ అనేది ఎజెక్ట్ అవ్వదు. అదే ఫర్ వైట్ ఇట్ హ్యావ్ వెరీ లెస్ వేవ్లెంత్, అంటే మ్యాక్సిమం వేవ్లెంత్కి కరెక్ట్గా ఫ్రీక్వెన్సీకి వేవ్లెంత్ కరెక్ట్గా ఉన్నప్పుడు ఎలక్ట్రాన్ అనేది ఎజెక్ట్ అవుతుంది. కాబట్టి ఫర్ రెడ్ లైట్ potassium metal, for potassium metal I am saying, see, nature of metal is different. Okay, for one different metals they are having different natures. So for potassium metal, violet light and yellow light also suitable for ejection of electron. Okay, now the threshold wavelength is that, and when we now let us discuss about work function. Okay, it's very important topic, work function. So what is meant by work function? The work function means the minimum energy required to eject the electron out of the metal surface. Now, the minimum energy, where we are discussing about energy, okay? The minimum energy required to just take out the electron from the metal surface. అంటే మెటల్ సర్ఫేస్ నుంచి ఎలక్ట్రాన్ ఎజెక్ట్ కావడానికి కావాల్సిన ఎనర్జీ, మినిమం ఎనర్జీని వర్క్ ఫంక్షన్గా డినోట్ చేస్తాం, విచ్ ఇస్ డినోటెడ్ బై W0, ఆల్సో కాల్డ్ as it is called as work function. Okay, see, if we take when the incident light having a sufficient energy to break the bond between the nucleus and what valence electron, valency, అంటే ఆ ఎనర్జీ అనేది సఫిషియంట్ ఎనర్జీ అనేది ఆ ఇన్సిడెంట్ లైట్కి ఉండాలన్నమాట. టు బ్రేక్ ద బాండ్ బిట్వీన్ న్యూక్లియస్ అండ్ valence electron, sufficient energy is needed. Okay, but So the minimum energy needed is called work function. Okay. The electrons are rejected. What happens if the energy of the incident light having more energy than required minimum energy? అంటే మినిమం ఎనర్జీ అంటే వర్క్ ఫంక్షన్ కంటే ఇన్సిడెంట్ లైట్ ఎనర్జీ ఎక్కువ అయితే ఆ రిమైనింగ్ ఎనర్జీ వాట్ హ్యాపెన్స్ టు ద రిమైనింగ్ ఎనర్జీ ఆ రిమైనింగ్ ఎనర్జీకి ఏమవుతుంది అనేది చూద్దాం. ద రిమైనింగ్ ఎనర్జీ ఈస్ కన్వర్టెడ్ ఇంటూ కైనెటిక్ ఎనర్జీ. ద ఎనర్జీ when the incident light energy having more energy than work function, then the remaining energy is converted into kinetic energy. And let us take example. The work function needed is 2 electron volts. Okay, అంటే మినిమం ఎనర్జీ 2 ఎలక్ట్రాన్ వోల్ట్స్ కావాలి మామూలు ఎజెక్ట్ కావడానికి ఎలక్ట్రాన్. బట్ ద ఇన్సిడెంట్ లైట్ ఎనర్జీ హ్యావింగ్ 3 ఎలక్ట్రాన్ వోల్ట్స్ విచ్ ఈస్ మోర్ దాన్ ద రిక్వైర్డ్ ఎనర్జీ. సో ద రిమైనింగ్ 1 electron volt is converted into kinetic energy. Okay, a remaining 1 electron kinetic energy convert అవుతుంది. Okay, this is a work function. Now let us derive the equation for the work function. E is equal to W plus KE. E is equal to W plus K. Here W is the work function and E is the energy. K is the kinetic energy. So according to Planck's quantum theory, E is equal to h nu. Kinetic energy is half mv squared. Now we have to take here work function h nu naught. The h nu naught అంటే threshold frequency తీసుకున్నాము ఈ సిచ్యువేషన్ లో. When here in this situation we are taking work function as h nu naught. Actually nu minus nu naught is nothing but work function. The incident frequency ki మన threshold frequency minus చేస్తే కూడా మనకి వచ్చేది వర్క్ ఫంక్షన్. అంటే ఆ మైనస్ చేసిన ఎనర్జీ రిమైనింగ్ ఎనర్జీ వచ్చేసి కైనెటిక్ ఎనర్జీ కన్వర్ట్ అవుతుంది. ఓకే, సో ద రిమైనింగ్ ఎనర్జీ న్యూ మైనస్ న్యూ నాట్, ఆ రిమైనింగ్ ఎనర్జీ షుడ్ బి కన్వర్టెడ్ ఇంటూ కైనెటిక్ ఎనర్జీ ప్లస్ హాఫ్ mv square. When we transport half mv square equal to h nu minus h nu naught. Half mv square equal to h nu minus h nu naught. Ke equal to h of nu minus h into nu minus nu naught. K equal to h into nu minus nu naught. It means half mv square equal to h into nu minus nu naught. What conversion we have to do when they ask velocity or velocity అడిగినప్పుడు? Here we have to derive the equation much. Okay, and v square equal to, here nu minus nu naught is nothing but work function. V square equal to 2h into nu minus nu naught by m. V equal to square root of 2h into nu minus nu naught by m. So this is very important equation. V equal to square root of 2h into nu minus nu naught by m. Okay, what we have to do when they ask wavelength? If wavelength is given and threshold wavelength, okay, when in the question when they give threshold wavelength, we have another equation also. Hc by lambda, E is equal to hc by lambda. See, E is equal to W plus Ke, right? Okay, E is equal to, according to Planck's quantum theory, we derived hc by lambda, right? So W equal to, here we have to take hc by nu, lambda naught. So the frequency we taken nu naught. Here we have taken lambda naught plus half mv square. So here lambda is nothing but incident wavelength. Here threshold wavelength. Here nu is nothing but incident frequency. Nu naught is nothing but threshold frequency. Okay, right. Now see what happens when the intensity of light increases. So when the intensity of incident light increases, what happens to the photoelectrons? Yes, one. Intensity means power of light, nothing but power of light. Here we have to keep in the mind that when intensity increases, the energy is not changing. Okay? Energy is not changing. Intensity increases means the number of photons increases. You know that light contains particles, energy bundles, energy packets called photons, according to Einstein's approach. Okay, photons, and the number of photons increases, not the energy is increases. Number of photoelectrons is not dependent on the energy. Number of photoelectrons, the electrons ejection is dependent on the energy. Here photoelectrons means the electrons ejected out. This we call as photoelectrons. And the electrons ejected electrons and photoelectrons అని అంటాం. ఈ నెంబర్ ఆఫ్ photoelectrons అనేది ఎనర్జీ మీద డిపెండ్ అవ్వదు. ఓకే, సో energy is required to eject the electrons, but it is not dependent on the number of photoelectrons. The number of photons, increases, the number of photoelectrons also increases. The number of photons increases means intensity increases. Intensity increases. Number of photoelectrons increases. Frequency will not change because frequency is not dependent on the number of photons. Okay, frequency is not changing. Which light is incident on the surface, that light frequency only will be there. In that how many photons will be, and any photons will be, but frequency మారదు. Okay, intensity increases, number of photoelectrons increases. Frequency does not change, energy also does not change, energy remains constant. E is equal to h nu only, energy will not change, E is equal to h nu. Okay, this is case 1. Now let us see case 2. So the energy will not change, energy is E is equal to h nu. And the kinetic energy also not changing in increasing of kinetic energy also will not change in increase of intensity, because what happened, just the number of photoelectrons is increasing. Okay, the energy is not changing means the work function also will not change, because the work function also the minimum energy required the constant value only. The work function will not change. So either the kinetic energy number of when the energy of incident light changes only, then the work function, the energy should be అంటే ఎనర్జీ అనేది వర్క్ ఫంక్షన్ కంటే ఎక్కువ ఉండొచ్చు, తక్కువ ఉండొచ్చు. కానీ ఇక్కడ ఇన్సిడెంట్ లైట్ యొక్క ఎనర్జీనే చేంజ్ కావడం లేదు కాబట్టి, అంటే విత్ ద ఇన్సిడెంట్ లైట్ ఎనర్జీ ఈస్ నాట్ చేంజింగ్ హియర్. సో ద వర్క్ ఫంక్షన్ kinetic energy will be released or will not be released, but not increases according to intensity. Okay, అంటే kinetic energy రిలీజ్ అయ్యిండొచ్చు ఆ ఎనర్జీ బట్టి, అంటే ఇన్సిడెంట్ లైట్ ఎనర్జీ బట్టి, అంటే kinetic energy రిలీజ్ అయ్యిండొచ్చు. కానీ ఇక్కడ ఇన్సిడెంట్ లైట్ ఎనర్జీ పెరగడం లేదు కాబట్టి కైనెటిక్ ఎనర్జీ కూడా ఎంత ఇంక్రీజ్ ఇన్సిడెంట్లో ఉన్నప్పుడు ఎంత ఎనర్జీ ఉంటుందో దాన్ని బట్టి కైనెటిక్ ఎనర్జీ రిలీజ్ అవుతుంది. కాబట్టి ఇంటెన్సిటీ ఎక్కువైనా ఇన్సిడెంట్ ఎనర్జీ ఎక్కువ కాదు కాబట్టి కైనెటిక్ ఎనర్జీ కూడా ఎక్కువ అనేది ఉండదు, అంటే గ్రోత్ అనేది ఉండదు. కైనెటిక్ ఎనర్జీ ఎంత రిలీజ్ అవుతుందో వర్క్ ఫంక్షన్ కంటే ఎంత ఎక్కువ ఉంటుందో స్టార్టింగ్ ఇన్సిడెంట్ లైట్ ఎనర్జీ ఉన్నప్పుడు అంతే రిలీజ్ అవుతుంది కైనెటిక్ ఎనర్జీ అనేది. ఓకే, ఇంటెన్సిటీ పెరిగే కొద్ది ఇన్సిడెంట్ లైట్ ఎనర్జీ ఎక్కువ కాదు, అలాగే కైనెటిక్ ఎనర్జీ కూడా ఎక్కువ కాదు. ఓకే, let us see about frequency. If frequency increases, kinetic energy increases. Okay, frequency increases, kinetic energy increases. ఫ్రీక్వెన్సీ ఇంక్రీజ్ అవుతాయి. ఇప్పుడు చెప్పండి, ఇక్కడ ఎల్లో లైట్ ఫ్రీక్వెన్సీ పడింది అనుకోండి, పొటాషియం ఎల్లో లైట్ ఫ్రీక్వెన్సీ, ఎల్లో లైట్ ఈస్ ఇన్సిడెంట్ ఆన్ ద మెటల్, it has one frequency, and so the nu minus nu naught value, it has some value, right? Nu minus nu naught, that is converted into kinetic energy. Okay, the new minus nu naught value is converted into the new minus nu naught value we are substituting as work function in the equation కదా. కాబట్టి అదే వైలెట్ లైట్ పడింది అనుకో, వైలెట్ లైట్కి ఇంకా ఎక్కువ ఫ్రీక్వెన్సీ ఉంటుంది కదా, అప్పుడు ఫ్రీక్వెన్సీ ఇంక్రీజ్ అయ్యే కొద్ది ఆ న్యూ మైనస్ nu naught వాల్యూ చాలా పెరుగుతుంది. ఇన్సిడెంట్ యొక్క ఫ్రీక్వెన్సీకి కావాల్సి పొటాషియం లైట్ మెటల్ తీసుకున్నాం, ఎల్లో లైట్ పడింది, ఎజెక్షన్ ఆఫ్ ఎలక్ట్రాన్ అవుతుంది, కైనెటిక్ ఎనర్జీ కూడా రిలీజ్ అయితే ఏదో పాయింట్స్లో రిలీజ్ అవుతుంది. అదే వైలెట్ లైట్ ఇంకా ఎక్కువ ఫ్రీక్వెన్సీ ఉండేది పడితే ఆ న్యూ మైనస్ nu naught వాల్యూ ఇంకా పెరిగితే అప్పుడు కైనెటిక్ ఎనర్జీ కూడా ఇంకా పెరుగుతుంది కదా. కాబట్టి ఫ్రీక్వెన్సీ ఇంక్రీజెస్, కైనెటిక్ ఎనర్జీ ఆల్సో ఇంక్రీజెస్. ఓకే, ఇన్సిడెంట్ ఫ్రీక్వెన్సీ ఎంత ఇంక్రీజ్ అవుతే అంత కైనెటిక్ ఎనర్జీ కూడా ఇంక్రీజ్ అవుతుంది. ఓకే, now let us see some graphs based on what we discussed now. I increase decrease ki graph చూద్దాం, very important graph. Here we have to understand one more point also. By increasing frequency, kinetic energy of photoelectrons increases, right? But number of photoelectrons is not increases. The number of photoelectrons ki kinetic energy కి సంబంధం ఉండదు అసలు, అంటే ఫ్రీక్వెన్సీకి. ఓకే, it is number of photoelectrons will release very quickly, as much as quickly as possible. Okay, ఎందుకంటే ఫ్రీక్వెన్సీ ఎక్కువ ఉంటుంది కాబట్టి మినిమం ఫ్రీక్వెన్సీ increases, right? Incident light frequency is more, it is more than the minimum frequency, then photoelectrons will be released quickly, but not the number will not be increased. Okay, number increase కాదు. Okay, now let us see graphs. Let us see first of all the intensity kinetic energy graph. అసలు ఇంక్రీజ్ అవుతుందా intensity kinetic energy graph? Let us see. When we take this point intensity, the kinetic energy is constant. When we take in this point intensity, the kinetic energy is still constant. When we increase the intensity, then the kinetic energy also is same constant. అంటే కాన్స్టెంట్ ఒకే పాత్, ఇంక్రీజ్ అనేది ఉండదు. ఇంక్రీజ్ అనేది మన గ్రాఫ్ ఇలా రావాలి స్ట్రైట్ లైన్, బట్ దెర్ ఇస్ నో ఇంక్రీజ్, కాన్స్టెంట్ వాల్యూ. కాన్స్టెంట్గా అలాగే ఉంటుంది కానీ ఇంక్రీజ్ అనేది అవ్వదు. kinetic energy is not increased by increasing the intensity. And let us take intensity photoelectrons. The graph is straight line. Because by increasing intensity, photoelectrons increases, as we discussed now only. Okay, now one more very interesting graph. Kinetic energy, frequency kinetic energy. See, this is work function value. This is work function value. Okay, see, this is a graph, kinetic energy, frequency. This is work function value. Work function value no value ఉన్నప్పుడు kinetic energy release అవ్వదు. When it is there, the frequency increases. Threshold incident frequency ఇంక్రీజ్ అవుతాయి, థ్రెషోల్డ్ ఫ్రీక్వెన్సీ కంటే ఎక్కువ అవుతుంది కాబట్టి న్యూ మైనస్ nu naught వాల్యూ కూడా ఒక వాల్యూ అనేది వస్తుంది. కాబట్టి కైనెటిక్ ఎనర్జీ ఇక్కడ నుంచి స్టార్ట్ అవుతుంది అనుకున్నాం, ఇక్కడ నుంచి స్టార్ట్ అయ్యి ఇంకా ఎంత ఇంక్రీజ్ అవుతాయి ఇన్సిడెంట్ ఫ్రీక్వెన్సీ, హౌ మచ్ ఇంక్రీజెస్ దట్ మచ్ ద కైనెటిక్ ఎనర్జీ ఆల్సో ఇంక్రీజెస్. ఓకే, దిస్ ఈజ్ వర్క్ ఫంక్షన్. This is work function. Here it is intersecting at y-axis, which means negative. It is not positive. The nu minus nu naught value, the work function should be in negative. The nu minus nu naught value, this is in negative. Negative with the y-axis, negative y-axis intersect what is negative not. Now one more very interesting. Here we have to discuss some points. Okay. See, let us discuss some important points. Based on this graph only, if the incident frequency is greater than the threshold frequency, what happens? We discussed now, incident frequency is greater than the threshold frequency, ejection of electron takes place, electrons ejects. Now the nu minus nu naught value is imported as kinetic energy, it is converted as kinetic energy. The nu minus nu naught value, it is converted as kinetic energy. Okay, when incident frequency is equal to minimum frequency, the threshold frequency is minimum frequency kada, so the incident frequency is equal to minimum frequency, ejection of electron will take place, but the nu minus nu naught value is 0. The nu minus nu naught value is 0, then the kinetic energy is not be converted. there is no energy to convert as a kinetic energy. Okay, so there is no kinetic energy. When incident frequency is less than threshold frequency, there is no ejection of electron. So minimum frequency it should be higher than incident frequency or equal. But it is when it is less than, then there is no conversion of ejection of electron. Now let us see one last graph. Nu minus lunar value. Let us take nu minus lunar value and kinetic energy. How we graph will become straight line? How? Nu minus lunar value, kinetic energy. What happens when nu minus lunar value increases? Then the kinetic energy it is converted into kinetic energy. But why there is one another way? అంటే మనం ఎందుకు ఈ స్ట్రైట్ లైన్ వస్తుంది, ఎందుకు ఇది ఆర్బిటల్ నుంచి పాస్ అవుతుందని చూపించచ్చు, మనం అలా ప్రూవ్ చేయొచ్చు. హౌ వీ కెన్ ప్రూవ్ దట్ దిస్ లైన్ ఇస్ పాసింగ్ టు ఆరిజిన్ అండ్ ఇట్ ఈస్ లైక్ ఎ స్ట్రైట్ లైన్ by comparing it to straight line equation. We know that Ke equal to h into nu minus nu naught, right? K equal to h into nu minus nu naught, and the straight line equation is y is equal to mx plus c. Okay, y is equal to mx plus c. So there is no constant, so plus 0. So the constant value is positive. The constant value is positive. Mx plus c. So it is going through origin. The constant is 0, so that it is passing through origin, and the y value is kinetic energy value. We taken y value. The x value is nu minus nu naught. We have taken the slope. M is the slope, so the m is the h. So slope equal to h. H means Planck's constant. H is Planck's constant, right? So slope equal to h. This we have to we can prove like this. Okay, slope is equal to h. Intercept, there is no intercept. There is no intercept actually. Okay. In the past graph, the intercept is minus because it is passing through the y-axis. Okay. This is about the graphs. Okay. Now we discuss a very small topic fastly. Working potential. Stopping potential. Stopping potential. And another important topic, this for JEE. Work function to this up to this part is full of JEE. Okay. Stopping potential is the acceleration required to stop the movement of ejected electron. And so the electron is ejected, so we have to stop the electron. The acceleration required to stop the movement of the electron is called a stopping potential. It is stated by V naught. There is one formula for stopping potential. C into V naught equal to Ke, where C is the velocity of retrieved within 400 meter per second, and C into V naught equal to, according to E is equal to W plus Ke. When you substitute E minus W is equal to Ke. What is E? H nu. So H nu minus W. H nu minus W. This is stopping potential. This is the formula for stopping potential. Okay, where C is the velocity, V naught is the stopping potential, and h nu is the energy, W is the work function. Okay friends, this is our today's class. Hope you understand this class, enjoy this class. Thanks for watching, and let us meet in the next video. Thank you.